Hey guys, I saw in the forum that people are looking for some info on how to implement DSP in Hise. So I'm going to go through that real quick. Alright, I'm on Linux, but that shouldn't affect anybody else. It works on all platforms. Alright, let's see. Let's make a new project here. Call it the Hise driver. Okay, then we of course need to restart for some reason. Alright, let's add our script effects. Create a new one here. Hise drive DSP. Then we're going to add in an Snex node. And then I also like to prototype the DSP with an oscillator and an oscilloscope. And so let's set this to like 603. And then we're going to turn this off too. I don't want to hear it. Okay. And the oscilloscope, so we can see what's going on the other end. Okay. All right, we'll create a new file for our DSP to go in. This will be driver DSP. And let's see here. Looking at the forum post, let's see, we have a few variables and a drive knob. All right, so we'll create a parameter called drive. And it says it goes from 0.1 to 5. So we'll add that in. Whoops. Whoops. Okay, so now we got a knob that goes from 0.1 to 5. All right, we'll open up our script editor. Click on the Snex tab, open it up. All right, now we have a script we can put our code into. So we'll start with the variables. There is a Z. There's an S. There's a B. And there is an A, which looks like it's the drive. So we'll add that in. And then I always like to look at the live view here, so we can see that our variables are in, that they're going to be doing what they're supposed to be doing. All right, so we have, I guess we can hook up our drive knob now. So we can go down to our parameter, and we'll use an index if p equals 0. So that's the index of this knob here. If you add more, it'll be index 1, 2, 3, 4, blah, blah, blah. All right, so if p equals 0, then we're going to do a equals float v. Whoops. Okay, so now we have our variable a, and if we turn this knob, we should see some kind of change that goes from 5 to 0.1. And we do, so that's working. That's great. All right, the next thing to do is let's make a function to iterate over the samples and process them. So we'll make this one get samples, float. Our input goes here. And we should update our variables. I guess the first thing, right? So looking at this DSP, let's see here, z equals pi times a. S equals 1.0 divided by math dot sine z, and b equals 1.0 divided by a. As it's iterating over the samples, it's going to update these values for us. Now we can process them. It says here, if input is greater than b, input equals 1. All right. Then else input equals math dot sine, oops, z times input, z times input times s. Okay. And then we need to return the input. Return input. Okay. Let's see here. We have our process and process frame that we need to enter. All right. So under process, S equals get samples S. Okay. And then in the process frame, I'm not sure if we need the process frame, but I'll put it in anyway. This is S, same thing. Okay, so now if we turn our drive knob, you can see our variables are updating, and we can also see by the oscilloscope that we are making some weird shapes. Now, I didn't plot this with MATLAB, so I have no idea if this is what this script is supposed to do, but this is what it's doing as written, so there it is. Alright, so let's save this. Next thing we need to do is we need to wrap this node in a DSP network. Wrap in DSP network, and we'll name this driver, oops, node. Okay, it says reload patch to apply. I've found that reloading the patch really doesn't work if you have a lot of other things going on. So I'll usually close the app and reopen. Okay. All right, we're still good. We're still good. Okay, so now you can see our node is it's been wrapped in a box. We can no longer see our DSP. If you did want to make some changes, you can click this little box here and go back into your node And now the next thing we need to do is wrap this as a DLL. So we'll go to export, compile DSP network as DLL. And we can see it's listed here as the node that's going to compile. And we'll make a release. Okay. Please run make. Okay, so I have to compile this externally. With Windows, it should just open up and compile. All right. All right, looks like it's done. Let's see if it did what it's supposed to do. Close Hise and reopen. Okay, so now we're compiled. We have our little snowflake on the node so that we know that it's frozen. And I'm also noticing that the DSP looks a little bit different in the oscillator after it's been compiled. I don't remember it looking like that. Anyway, that's how you do it. Good luck.